Hello members of Tambol Math class. I have two interesting word problem questions for you today. And here is the first one. The first question here reads, 12 men can complete a job in 15 days and 10 women can complete the same job but in 24 days. 9 men starts, this should be only one start. 9 men start working and after 6 days, they are replaced by 12 women. In how many days will these 12 women complete the remaining work? Forget about all the work done formulas. Let us analyze this question. Let's assume this is maybe a piece of land they are working on or anything. Let's assume this is the work. Since we don't know the magnitude of this work, we can declare it with X. Another thing most of these questions usually fail to explain is the efficiency. So we have to assume that all the men can work at the same rate. They have the same energy, capacity, and everything. So that's our first assumption, and this is the second one. So here we have 12 men working on this piece of land. If it is a land, and they're going to finish the work in 15 days. Let's assume we have the same work here, the same work. But for women, how many of them? 10. 10 of these women can complete this work in 24 days. 24 days. I'm trying to bring out something very interesting. So, what if you decided to find out the rate per day, right? If they can work the whole entire everything here in 15 days, then in one day, these 12 men can work only 1 out of 15 of the total work. So these 12 men can work only 1/15 of the total work, which is X. And for this one, if you just consider the work for a single day, then 10 women can work a fraction of what? 1/24 of the total work, X. Now, what if you want to find the rate at which one person here work for a single day? It is equivalent to dividing both sides by 12. So you have one man, only one man, because I want to find out the rate at which 9 men can work together. One man can work, if you divide this by 12, it is going to be 1/15 multiplied by the reciprocal of this, which is 1/12. This is going to give us 15 times. This is 180, right? This is 180 X. The same thing here, one woman can work, if you divide both sides by 10, you have 1 divided by 240, right? Of this total work, X. Now, second stage, we are done with the upper one. 9 men started the work, and they only work for what? 6 days. So 9 men is equivalent to multiplying both sides by 9. And if you do that, should I do that directly? Because I know that if I should multiply this by 9, it is going to give us 9/180. All right, subsequently, I'm going to delete up. Let me just write it. 9 divided by 180 X. And here, the remaining women that's going to take over, there are 12, right? Here we have 12 of them, 12 women, which are eventually going to take over. 12 divided by 240 X. All right, in 6 days, meaning this is for one day, right? Remember, we started with a fraction of 1 over 15, which is equivalent to 1 day after this moment. So 9 men in 1 day. So in 6 days is equivalent to multiplying by 6. But let me reduce this one. 9 men. 9 into 9 is 1. I can even multiply by x. So I have x divided by, this is 20. Because 9 into 180 is 20. Let me do the same thing here. 12 women. This is 1 over 20 as well. Right? Okay, yeah, this is x over 20. Very interesting. X over 20, because 12 can divide itself one time and it can divide 240 exactly 20 times. If you multiply by x, you have x over 20. So let me wipe up and continue. I'm trying to bring something interesting here. All right. So what's happened if the men work for 6 days? For 1 day, it is going to be x over 20. Second day, plus x over 20, plus x over 20 in 6 places, which is equivalent to multiplying by 6, right? So in 6 days, it will be what? 6x divided by 20. But the question is asking us to determine the number of days these people, the 12 women will complete the remaining work. So we don't know the number of days because it hasn't been specified, but we can declare it with something. So I can say in y days, since I don't know the number of days, it will be what? Just the way we multiply this by 6, we're going to multiply this by y. So it is going to be xy over 20. But remember, these people started for 6 days, they stop. These people continue for a number of y days to complete the job. So this work plus this work will be the complete work which we declared with x indefinitely. This is not the only way to solve this problem, but I think this is much simpler. So if I take 6x, divide by 20, and I add it to xy, divide by 20, we shall obtain x. And we can divide both sides by x, so we have only the numbers. We have 6 over 20 here. Oh, let me just do it. 6 over 20 plus y over 20 equal to 1 if you divide both sides by x. So let me continue the solution here. By adding the fractions, or you can simply multiply every single term by 20. So you have this times 20 is 6 plus y equal to 20. We multiplied each and every single term. And y, which is the remaining number of days for the 12 women to work, to complete the work, is going to be 20 minus 6, which is equal to 14. And remember, this y stands for the number of days, y days. So this is what? 14 days. As simple as that. All right, now anticipate the next question, which is also under word problem.